Hello. Today is chapter 8 closure, and I know we usually do this by yourself, and I don't help you. So you can pause it right now and do the problems and then come back and look at it because I'm going to give you some help on all the problems. So pause, work on it, and then come back. Welcome back. I made a list of what we studied in this chapter. Let me come over here. Just to sort of sum it up. So we talked about mean, which is the average, adding up all the numbers and dividing it by how many numbers in that set. We talked about the median, which is the middle number. We talked about the mean absolute deviation, which is you have a list of data. What's the average amount your data is spread? How far away from the mean is it? So you have to get the mean first and then find out how far in absolute value it is, each number is away from that mean, and then add all those up and find a mean of those numbers. So it's a way to measure how tight your data is. Like the people in our class, the ages in our class, very tight. You guys are almost all pretty much the same age. We talked about box plots and interquartile range, which are these guys. We got the whiskers. This is the first quartile. This is the third quartile. We talked about at the very end, distance over time equals rate. Really handy equation to know. Talked a little bit about unit rate, something per hour or per bag or per whatever. Doesn't always have to be time or running distance. I mean, it always has to be time, but it doesn't always have to be distance. And then at the very end, we talked about equivalent measures. So you have to measure like 60 seconds in a minute. You can't compare seconds and minutes. You have to compare minutes and minutes. Okay, so the first problem for 8.1, or not 8.1, for 8 closure is number 121. So I just wrote on my fireplace. Came off. What is this question? Oh, let me share the screen. But I had the book open. I didn't, sorry. I'm wasting my 15 minutes. Oh, it is open, it's right there. Okay, so 121. Evan is trying to save his money to buy new parts for his bike. He saved $27, which is 45% of what he needs so far. So he needs, if you can even just think about it in, this is 100%. This is 50. And somewhere taking off 3%, that looks like way more than 3%. 3% is 47%. So he has saved 47% for his total. And this is, let's write it in green dollars, 27 bucks. So if we wanted to estimate, here's our diagram and an equation with multiplication that represents this situation. So he needs to, they don't tell you exactly what the equation needs to represent, but let's say it just represents how much money he has now. I guess they kind of say that. So we're going to say 47%. Is it 45%? No, it's 45. Oops. Oh, it still looks about 45. I'm sorry. 45% times x. And we know, hopefully, we remember that 45% is 0.45 as a decimal. Times the bike equals $27. So that's the equation for A. B says, how much money will Evan's new bike parts cost? So now we want to find out, we know what 45% is, but we want to find out the other 55%. So we're going to figure out what x is, and we're going to divide both sides by 45. And we we have 27 divided by 45 equals $60. Oh, well, that does show us how much the bike costs. Yeah, so X equals the cost of the bike, and we know his bike, that's a cheap bike. Can't buy a bike for 60 bucks anymore, I don't think. Maybe, a used bike. Oh, it's his parts. Never mind, bike parts. So his bike parts are X, not the bike. And that's gonna be $60. How much money does he still need to save? That's super easy. You're gonna subtract 27 from 60. So I'm not gonna do that one for you. Sketch the algebra tile shape at right on your paper. I like the algebra tiles. Sometimes, not really. I don't like the algebra tiles. It's okay, we can admit it. So here we have X. So this length is X, this length is 1, just to refresh your memory. Then we have X squared, and we have another X. This is X squared, this is X, 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 X. These lengths are variables, it can be any number, but all the X's are the same number. And then a little guy right here, another X, and this is just 1. This is the unit square 1. So we've looked at it, we've drawn it. Write and simplify an expression. This is so easy, you guys. You're gonna love it. So we wanna combine the like terms. This and this are like terms. So that's a 2x. And I wanna start with the largest exponent first when I'm writing them out. There's only one of these. So my equation is gonna be x squared plus 2x plus 1. That represents, this is the algebraic equation represented by those tiles. And then you got B to evaluate your expression for X. If X equals 5.5, you're going to put a 5.5 in for every place you see X. So you're gonna have 5.5 squared plus 2 times 5.5 plus 1. Solve it. That should be easy. Hopefully you can do that on your calculator. 23, Aaron is a mountain climber. He has ascended to the top of Pikes Peak in Colorado. Top of Pikes Peak is 14,115 feet above sea level. He begins to descend at an average rate of 1,210 feet per hour. After 3.5 hours, what is his new elevation? So this is cool. They've given us feet and feet, and they told us his time in hours, and they want to know what is his new elevation. So let's draw a diagram. I have been on Pikes Peak, only in a car though. You can drive up to the top of Pikes Peak and look out, it's pretty cool. So here we have Pikes Peak. We have 14,000 feet. And we have the climber. And he's at the top, and he's going down to the floor. And he's going at 1 to 10 feet per hour. So in 3.5 hours, all we have to do is there's 1 hour. This isn't to scale. There's 2 hours. There's 3 hours. And then half is going to be 605, right? So in 3.5 hours, he's gonna go about 1, 2, 3, 6, 4,000 something. So I'll let you guys figure. Wait, 9,000. Yeah, is this the right one? 123. Oh, because it's what's left. So when you find out how far he's gone, let me just add these up. Well, you can find the answer, right? You guys know where to find the answer. So he's gone 4,235, and we want to find out how much he has left. So you need to subtract that, and you'll get some 9,000 something. Okay, so 124, and then we'll go up. Ooh, 126 is long. We're not near the end. How far along are we here? To show you. Netflix bar. Oh, 9:58. 5 more minutes. Okay, maybe we'll do 2 videos for this. So I don't need to rush it. Who needs to rush anymore, right? Copy the following expressions on your paper and simplify them by combining like terms. Like terms being anything with an x can be combined with another x. Anything with an x squared, here's 2x squared, can be combined. Anything that's just a number can be combined. You guys know you can add 4 plus 4, right? It sounds, when they put it in this kind of direction, it sounds confusing, but you really do know that you can add 4 plus 4. There's nothing wrong with that. So let me do one of these. How about that? 2a. 2, and this is using the distributive property, times 2x plus 1. So this 2 is going to be multiplying that number and that number. Plus 2x plus x squared plus x. So I'm going to work this out first. So this equals 4x, because 2 times 2x is 4x, plus 2, 2 times 1 is 2, and then just add the rest of this on again. 2x plus x squared plus x. Now I'm going to combine the like terms. We have x, x, and x. Here I can combine 4, 5, 6, 7. So I'm going to have 7x. I'm going to put the x squared first. So I like to go in descending order. And then the 2 is all by itself. So do the rest of those 3. Hopefully that's pretty easy to maneuver. 125. Over the summer, Gabriel reads books that had 192, 202, 175. Ooh, now we're going to find central tendency, right? So we have a list of numbers. We have 1, 2, 3, 4, 5 numbers, and he read 5 books. Choose the appropriate measure of central tendency and find the average mean number of pages in the books he read. So, they said to find the appropriate measure, but then they say find the mean. So basically, the mean is the appropriate measure. They answered that one for us. There's a car going by playing loud music. So I'm going to add all these up. I'm going to add up 192, 202, 175, 219, and 197. And whatever those add up to be, I'm going to divide it by 5. So this total divided by 5 equals the mean. So I'm going to let you do that on your calculator.